Okay, so today we're going to talk about the second half of translations. This mainly deals with vertical stretches and shrinks, and we'll kind of see what happens. So we're going to go back to our old friend, the parent function of a parabola. And now what we're going to do is we're going to multiply everything by 2. So you're going to have y equals 2x squared. So take a second to think to yourself what the graph is going to look like, and then we'll take a look at it here in a second. Okay, so you see the 2x squared is this blue line here. Okay, thinking about this, we took our values from our parent function and now we multiplied them by 2. So if we go back, zoom in here. So in our parent function, we had this ordered pair 1, 1. But now we're multiplying it by 2, and now we have 1, 2. So all our outputs were multiplied by a factor of 2, which is the 2 out in front here. So when x was equal to 2, we got 4. And now in our blue graph, we're multiplying everything by 2. So I expect when x equals 2 in the blue graph for that to be 8. We kind of zoom out here. We see when x is 2. It's a little hard to see. 5, 6, 7, 8 right here. Okay. So everything is, all our outputs are being increased by a factor of 2. This here is what we call a vertical stretch. Okay. We're taking our parabola and stretching it vertically. So you can think to yourself, well, I guess we'll put that one back up too. What is this one going to look like? The 3x squared. Okay, well, we should think it's going to be very similar to the blue one, except now all our values, our outputs, are being multiplied by 3. So they're increasing 3 times as fast. Okay, and we obtain this right here. So if we look, when our parent function's 1, I'll erase this second one here. I guess we'll keep it up. When our parent function's 1 in the red graph, it's 2 in our blue graph, and 3 in our green graph. Oops. Okay. The final one I want to talk about is this guy, not the final, of these vertical stretches, is this guy right here. Okay, a lot of people will think, well, it's not really going to be a stretch because you're increasing by a factor of -2. That doesn't make too much sense. But remember, all this negative sign does is reflect. Okay, so this is still a stretch, still being stretched by a factor of 2, but now it's just reflected. So there we go. So if you took our original blue one here, okay, this is y equals 2x, and now we just reflected it. So all that negative sign does is it reflects, just like it did before when we learned this. Okay, now we're going to go back to our parent function, and now we're going to look at ones that have this little fraction in front of it that's less than 1, so 1/2. And let's take a look at there. Now this graph became a little bit more wide. Well, why is that? Well, if you think, you're taking all your outputs from your parent function, and now we're multiplying them by 1/2 or cutting them in half. So it's going to take longer for them to grow because we keep cutting them in half. Okay. So in our parent function, when x is 2, y was 4, but we cut it in half. So when x is 2, y is only 2 in this new function here, this new equation. Okay. Take a guess at what's going to happen here. Okay. Hopefully you saw. Now we're taking all our values and decreasing them by a factor of 3. Interesting. Interesting. So it looks like the smaller this fraction gets, the more wide our parabola gets. We call this a vertical shrink. We're taking our parabola and shrinking it vertically. We're kind of bringing it out here. So we're shrinking it vertically. Now, one common misconceptions that students have is they think, oh, whenever it's a fraction, it's always a vertical shrink. Well, look at this case here. We have y equals 5 halves times x squared. And most people think, oh, this is a shrink, so it's going to be a little bit wider. But when you graph it, you see the black here actually shows it as a stretch. Well, if you think to yourself, 5 halves is 2.5. So what you're doing is you're taking your output values, multiplying them by 2.5. So that gives us a stretch situation. Okay. So just because it's a fraction doesn't mean it's always a shrink. You got to kind of think to yourself, if it's greater than 1, then we're going to have the stretch situation. And if it's less than 1, then we have a shrink. And remember that the negative sign, so let's say here you had a negative 1/3, okay? The negative sign only affects it with respect to being a reflection. So there. And same thing if you had a negative 5 halves, well, still not a shrink, it's still a stretch, but now it's reflected. Okay? Okay, now take a second and try to do these, describe their translations, and we'll see if you're right. Okay, welcome back. Be sure to pause the video if you're still working on it. Okay, looking at the first one here, from what we learned yesterday, we see that there are no parentheses, so we're not going to have a horizontal shift, but we do have a vertical shift, so up 3, and then this 2, it becomes a vertical stretch. So we're expecting a shift of up 3 and a vertical stretch of 2. We went up 3, and we have a vertical stretch of 2. Great. This next one here, we have parentheses, so we have a horizontal shift. And remember, it's opposite what we think. So you'd think to go to the left 2, but we're going to move to the right 2, go down 4, and now since we have a fraction that's less or in between 0 and 1, we're going to have a shrink. So we have a shrink of 1/3. We're going to go right 2 and down 4. Look at that. Right 2, down 4, shrink of 1/3. It looks like a huge parabola, but that's only because of the window that we're viewing it in. Okay, final one. Okay, here we have the no parentheses, so no horizontal shift. We have the +4 at the end, so we know we're going up 4. Now we got to think, what does this -4 do? Well, remember, if you're saying shrink, remember, all the negative sign tells us is that it's a reflection. So we know this is going to be reflected, and the 4 tells us we have a stretch. So this is a stretch of 4. We went up 4, and it's reflected. Went up 4, there's your reflection, and you can tell it has a little bit of a stretch with it. Okay, final one I want to talk about kind of expands on our reflecting. Okay, I've had a few people come up to me and say, okay, well, I understand that this here is a reflection, and we went right to, okay, there we go. We are pretty comfortable with that. But a lot of people feel like the negative sign should be with the x. Okay, and when you see this, you're going to think it's a reflection. But we know that this is how our graph should look. Now let's take a look at what this graph looks like. It's not reflected. This here, these are some properties of square root, or not square roots, some properties of exponents that kind of go into play here, okay, that we talked about last chapter. If you want more information on that, send me an email. But just realize when you have that negative sign, it has to go outside your parentheses. Otherwise, you're not going to have a reflection. Okay. So hopefully this helped. Hopefully you got the stretches and shrinks down. You have 5 total translations: stretch, shrink, up and down, left and right, and a reflection. Be sure you feel comfortable with all of them, and let me know if you need any help.